Good morning, everybody. Today I will discuss plane of regression. The equation of the plane of regression of x1 on x2 and x3 is given by x1 is equal to b12.3 x2 plus b13.2 x3, that is equation number 1. Here the constants b is in equation 1 are determined by the principles of least squares, that is minimizing the sum of squares of the residuals is given by, that is s is equal to summation x1.23 square is equal to summation into bracket, substitute the x1.23 value, that is x1 minus b12.3 x2 minus b13.2 x3, that bracket square. The summation being extended to the given values of the variables. Here n observations on each of the variable x1, x2 and x3. Therefore, the normal equations for the estimation of b12.3 and b13.2 are given by, that is partially differentiate with respect to b12.3 and b13.2 and equating to 0. Now, to s with respect to dou b12.3 is equal to 0, that is equal to minus 2 into summation x2 into bracket x1 minus b12.3 x2 minus b13.2 x3. Similarly, with respect to b13.2, that is dou s with respect to b13.2 is equal to 0 minus 2 into summation x3 into bracket x1 minus b12.3 x2 minus b13.2 x3, that is equation number 2. Summation x2 into x1.3 is equal to 0 and summation x3 x1.23 is equal to 0, that is equation number 3. This implies summation x1 x2 minus b12.3 summation x2 square minus b13.2 summation x2 into x3 is equal to 0. Summation x1 x3 minus b12.3 summation x2 into x3 minus b13.2 summation x3 square, that is equal to 0. That is equation number 4. Since exercise is measured from their respective means, we have sigma 1 square equal to 1 upon n summation xi square, since expectation of x is equal to 0, and covariance of xi xj is equal to 1 upon n summation xi xj, and the correlation coefficient Rij is equal to covariance of xi xj divided by sigma into sigma j, that equal to 1 upon n summation xi xj divided by sigma into sigma j, that is equation number 5. Therefore, n into Rij sigma j is equal to summation xij. Using this relation, find out equation number 4. From equation 4, we get n r12 sigma 1 sigma 2. Already you know previous equations, summation x1 x2 is nothing but r12 sigma 1 sigma 2 minus b12.3 n into sigma 2 square minus b13.2 n into r23 sigma 2 sigma 3, that equal to 0. n r13 sigma 1 sigma 2 minus b12.3 n r23 sigma 2 sigma 3 minus b13.2 n sigma 3 square is equal to 0 using the equation number 4 and using and relation n into Rij is equal to sigma I sigma j, that is equal to summation xi xj. That above terms simplified, that is r12 sigma 1 sigma 2 minus b12.3 sigma 2 square, here n is take common, minus b13.2 r23 sigma 2 sigma 3 is equal to 0, R13 sigma 1 sigma 3 minus B12.3 R23 sigma 2 sigma 3 minus B13.2 sigma 3 square is equal to 0. That is equation number 6. Solving the equation 6 for regression coefficient B12.3 and B13.2, we get modulus determinant of R12 sigma 1, R23 sigma 3, R13 sigma 1, sigma 3. This divided by determinant of sigma 2, R23 sigma 3, R23 sigma 2, sigma 3, that equal to, take numerator sigma 1 sigma 3 and numerator sigma 2 sigma 3 common. That is sigma 1 into sigma 3 determinant of R12 R23 R13 1 divided by sigma 2 into sigma 3 determinant of 1 R23 R23 1. Therefore B12.3, that is regression coefficient, sigma 1 upon sigma 2, because sigma 6 sigma 3 cancelled, determinant of R12 R23 R13 1 divided by determinant 1 R23 R23 1, that is equation number 7. Similarly B13.2 equal to sigma 1 upon sigma 3 into determinant of 1 R23 R12 R13 divided by determinant of 1 R23 R23 1, that is equation number 8. If we write omega is equal to 1 R12 R13 R21 R23 R22 R23 R31 R32 R33 is nothing but 1, R22 is nothing but 1. Therefore omega ij is the cofactor of the element in the ith row and jth column of omega we have from equation 7 and 8. Therefore B12.3 is equal to minus sigma 1 upon sigma 2 omega 1 2 by omega 11. B13.2 minus sigma 1 upon sigma 2 omega 13 divided by omega 11, that is equation number 8. Now substituting these values in equation that is x1 is equal to b12.3 x2 plus b13.2 x3, we get the required equation of the plane of regression of x1 on x2 and x3 has x1 is equal to minus sigma 1 upon sigma 2 into r12 by sigma omega 11 omega 12 by omega 11 into x2 minus sigma 1 upon sigma 3 into omega 13 by omega 11 x3 x1 plus sigma 1 upon sigma 2 omega 12 by omega 11 x2 plus sigma 1 upon sigma 3 omega 13 divided by omega 11 x3 is equal to 0. Sigma 2 sigma 3 omega 11 x1 plus sigma 1 sigma 3 omega 12 x2 plus sigma 1 sigma 2 omega 13 x3 divided by sigma 2 into sigma 3 omega 11, that equal to 0. That on simplification sigma 2 sigma 3 omega 11 x1 plus sigma 1 sigma 3 omega 12 x2 plus sigma 1 2 sigma 1 into sigma 2 omega 13 x3 is equal to 0. Now this step divided by sigma 1 sigma 2 sigma 3, we get x1 upon sigma 1 omega 11 plus x2 upon sigma 2 omega 12 plus x3 upon sigma 3 omega 13 is equal to 0, which is the required plane of regression of equation x1 on x2 and x3. This equation also use alternative method. Now eliminating the coefficient of b12.3 and b13.2 in equation 1, we get, that is x1 is equal to x1 is equal to b12.3 x2 plus b13.2 x3. On equation 6 we get r12 sigma 1 sigma 2 minus sigma b12.3 sigma 2 square minus B13.2 R23 sigma 2 sigma 3 is equal to 0. R13 sigma 1 sigma 3 minus B13.2 R23 sigma 2 sigma 3 minus B13.2 sigma 2 square is equal to 0. Now the required equation of the plane of regression of x1 on x2 and x3 using the determinant, that is determinant of x1 x2 x3, that is first row. Second row r12 sigma 1 sigma 2 sigma 2 square r23 sigma 2 sigma 3. Third row r13 sigma 1 sigma 3 r23 sigma 2 sigma 3 sigma 3 square, that equal to 0. Now dividing C1, C2 and C3 are called columns by sigma 1, sigma 2 and sigma 3 respectively, and also row R2 and R3 by sigma 2 and sigma 3 respectively. We get determinant of sigma x1 upon sigma 1, x2 upon sigma 2, x3 upon sigma 3. Second row R12 1 R23. Third row R13 R23 1, that equal to 0. This determinant is simplified. We can get x1 upon sigma 1 omega 1 1 plus x2 upon sigma 2 omega 1 2 plus x3 upon sigma 3 into x13 is equal to 0. This is also required plane of regression of equation x1 on x2 and x3. Thank you.